Hello everyone. Today we're going to review a little bit more solving some inequalities. So solving some things that look a little bit different than an equation. You're going to need to take some notes and you'll probably want a calculator as well. Take a minute and write this chart into your notes. See the little pencil up in the upper left-hand corner? That's my new way of telling you when we need to write things in our notes and when we don't. That way it becomes more of a visual marker. Some things that you should keep in mind. Equations we've already done, and inequalities we're about to enter into right now, and there's some differences. In terms of symbols, equations have an equal sign. That's what makes it an equation. Inequalities will have a less than, a greater than, a less than or equal to, greater than or equal to, those symbols that you've seen before. That's what separates them in terms of their symbols. How we go about solving them is pretty similar. We're going to do inverse operations to isolate that variable. We're going to continue to do the opposite of what we're seeing there in order to get the x or the y or whatever it might be alone. The only thing we need to try to remember this time is that inequalities have some special rules, special things that happen every so often. When solving, if you happen to divide or multiply by a negative number, remember to flip that inequality sign. And then inequalities also require us to sketch our solutions on a number line, since we're talking about more than one number answers. Now let's do some examples. You will want to write this one in your notes as well. Here's an example. We're going to work to try to get x by himself. So just like an equation, we're going to go ahead and do inverse operations, adding 2x. 6x plus 2x is 8x. 8x greater than 32. And now dividing by 8, we get x is greater than 4. Now when we sketch these on a number line, we're going to want to make sure that obviously the number 4 is on our number line and maybe some numbers on either side of it. And then remember, when you sketch these solutions on a number line, we're trying to show all the answers that are greater than negative 4, since our answer was x is greater than negative 4, or greater than 4. So I will go to my number line, and on the 4, you will want to put a dot. Now, the type of dot is special here. We want only x values that are greater than 4, so we don't actually want to include the number 4, hence the open dot. And then I have my student shade here on this number line, make a pretty obvious arrow, saying that all of those values going to the right there are the ones that show where x is greater than 4. You may remember that a little bit differently from Algebra 1, depending on how you teach or had you mark those number lines. But it's kind of a similar fashion. Open dot, showing that arrow where all the solutions are. Let's do another one like that. This one we have 10 is less than or equal to 6 minus 4x. So if I'm trying to get x by himself, I might subtract 6 here. And I would get 4 less than or equal to negative 4x. And this is a situation where I'm going to divide by the negative 4. And remembering that special rule, when you divide by that negative, the inequality flips sign. So it becomes what was written as a less than sign there becomes greater than. So this 4 divided by negative 4 is negative 1. And we have x on the other side all by himself. So we know on our number line we're going to need negative 1. We know we might also put a 0. You know, we might also put negative 2 on there. And we're going to place a closed dot on negative 1 this time because it's greater than or equal. See this little equal to dot guy down there? He's telling me that I want to include the answer of negative 1. So I'm going to close that dot. And then be careful which way you put this arrow. It says negative 1 is greater than or equal to x. Well, if I read that backwards, that means x, it has to be less than or equal to negative 1. So when you draw your solutions on that number line, whoa, got a little crazy there. When you draw your solutions on that number line, he's actually going to show all the values that are less than or equal to negative 1. Now, what can happen is sometimes you can end up with compound inequalities. Just when you get the hang of a single inequality, we're going to make more than one happen in one problem. They might look like this, where you have 2 of those symbols instead of just one inequality symbol. Or they might actually have the physical written word or in between that. It doesn't mean you choose your favorite problem. It means you have to do both, and you're going to get a situation where you're graphing 2 situations on that number line, or you're using 2 pieces of information to describe the solution. So let's look at one of those compound inequalities. This one has a less than and a less than or equal to symbol in them. So this one is an example of where that compound inequality is actually representing two separate inequalities. This is like saying negative 12 is less than 3x minus 1, as well as the 3x minus 1 is less than or equal to the 3. The 3x minus 1 goes with both halves of that compound inequality, if you will. And you can solve those separately. I could add the 1s and divide by the 3 and solve those separately. Sometimes people like to keep them together and solve them together. So in this case, I'll focus my attention, if I want to keep them together, I'll focus my attention on that algebra expression there in the middle, and I'm going to try to isolate that x just like I would do any other time. I'm going to add 1 to eliminate that negative 1 right there, but I need to remember to add it on both halves now of that inequality, because it's really representing two separate inequalities. So I'd end up with 3x, 3 plus 1 is 4, negative 12 plus 1 is negative 11. Okay, and now I'm going to divide by that 3. And I'm just going to leave those answers as fractions. Feel free to think about them as a decimal approximation as we go to make this number line. So on the number line, I'm going to need to put these values on there. 4/3 is the same thing as 1 1/3. So I'm going to need to think about putting some numbers on there. These are my integer values, okay? And now I'm going to space or place these numbers on that number line. 1 1/3, it would be a little bit past 1, and I want to put a closed dot on that guy, and I'm going to label them as 1 1/3 or 4/3. And I'm also going to place a dot on my negative 11/3, which is just a little bit before negative 4 here, or between negative 3 and negative 4. So for this guy, we're going to place an open dot there. And now let's read our inequality to decide which way we're going to draw these arrows here. It's showing that x is less than or equal to 4/3, but x is also greater than negative 11/3. So if he's less than this guy, but greater than this guy, essentially we're finding all of those solutions in that region in between those two values. Okay, so this is what the graphical picture of that number line might look like. I'm going to just mark this open dot with negative 11/3 there so we know which value that is. Okay, that's an example of what a compound inequality may look like. Sometimes your compound inequalities have the word or in between them. And like I said before, that does not mean that you want to solve your favorite. Okay, this is not a do this one or this one. It means they both play a part in that solution. So we need to actually solve both of them. But they don't really have anything in common, so we're not looking at them in the same way as that other compound inequality. We actually have to do both problems. So I'm going to solve this first one, negative 9x, 14 subtract 5 is 9. Now I'm going to divide by negative 9. Careful, I'm dividing by a negative here. Flip that inequality around. Okay, x is greater than negative 1. Then I'm going to solve that other guy. That's one part of my solution. The other part of my solution will come from this other inequality. Add 17, negative 4x, greater than 20, dividing by negative 4. Again, I'm dividing by a negative, so remember to flip that inequality symbol around. 20 divided by negative 4 is negative 5. So when we go to place these on our number line, we're going to need to make sure we have a negative 1 and a negative 5. Be sure that you know where they're located on the number line. If this is 0, this might be negative 1, negative 3 might be here, negative 2, negative 4, negative 5, negative 6, okay? And we're going to place some dots on those values, place some points. So I'm going to start with the first part right here. X is greater than negative 1, so I'm going to place an open dot on negative 1 because we don't want to include negative 1 value, and I want to show all the solutions that are greater than negative 1. So that's all these guys that way to the right. And then I'll do the same thing for my other half of my solution. X is less than negative 5. So on the -5, another open dot, and I need to show all the solutions that are less than that value. So this compound inequality doesn't have all the solutions in between the two. Instead, they happen to go in opposite directions. Watch out for that when you're making your number lines. Okay, that's it for today. That's a quick review of inequalities. Thank you very much, and we'll see you tomorrow.